In an earlier lesson, we began speaking about what functions are. Functions are a specific type of relation where every input will have only one output. Okay. And the examples we looked at always had data given to you in terms of numbers, maybe in the tables, maybe in ordered pairs. There's another way to determine if something's a function, and that's by graphing and using what we call the vertical line test. Okay, the vertical line test states that a graph represents a function when no 2 points on the graph lie in the same vertical line. Okay, maybe we should highlight that. No 2 points on the graph lie on the same vertical line. To use the vertical line test, place a ruler. You actually don't need a ruler. You can do this by visual inspection. Okay, and you're going to see by looking at it, is this a function? So for example, I'm going to draw a vertical line through this graph. You can see that it crosses the graph in two places. This would say that it's not a function. And the reason it's not a function is the input value of 2 has an output value of 2, but it also has an output value of -2. Okay, and so you can see, if we were doing that, the arrow diagram, you can see that 2 would have 2 different outputs. That's not a function. So we're going to say no function here. Okay, if you look at the next one, no matter where I draw a vertical line, it's always crossing only in one point. Okay, so this, yes, is a function. Okay, so it's that simple. You should be able to just look at the graph and say function or no. If you draw a vertical line here, there's no way I can get through 2 different points. So yes, this is a function. On the other hand, here, if I draw right here, you can see there are 2 outputs for the same input. The input being 8.5, 2 outputs. So this is not a function. Okay. So got the idea of a function. We're going to spend some more time on domain and range here. This is probably the hardest part of this unit. It's new. So trying to write domain and range, when we first started it was really easy. But that was when there was a specific list of values. What we're going to do now is you're going to see that there's a range of values, and there's other ways to show what the domain and range are. Okay, we have 2 ways to do it. We have the set notation and we have interval notation. Set notation uses the greater than or less than symbols. You probably remember seeing these. Okay, it also uses these 2 symbols. This is an element of, and then the funny looking R there is just representing the real number system. Okay, so let's do an example to show you what this means. Here's the example. We're supposed to find the domain of a function where every x value is equal to or greater than. So equal to or greater than is going to be this symbol. Okay, that's greater than, that's equal to. How do I know which one's greater than? Well, you're always reading left to right. So when I read left to right, what do I see first? I see the bigger side of the arrow. Okay, so greater than and equal to is that little extra line. And it says greater than or equal to -6. Okay, if you were going to draw a number line, and I would put -6 on here, that means 0 would be here. If I would want to show greater than -6, I would say it's bigger than -6, like -5, -4, -3, etc., etc. And because I have the word equal to, I'm going to put a solid dot there. If it didn't have equal to, then I would put a hollow dot there. Okay, it would look like that. But this one's equal to, so I have a solid dot there. So that's what I'm talking about, bigger than -6. How do I write that in set notation? I'm going to say x is greater than or equal to -6. And then I'm going to do something you haven't seen before either, such that x is an element of the real number system. Okay, what does that mean? Well, first of all, this says x is bigger than -6. Got that. What kind of numbers are x? Real numbers means I can have all the decimals, all the fractions, all the integers, all the whole numbers, any number you can think of. Okay? Now, this second part, I don't expect you to put. All right, I'm going to be okay if you just say x is greater than -6. All right, but we'll try and do something like that. We'll try to get used to it. All right. Recall the real number system includes all integers, fractions, and I only put 2 spaces here, but I mean and decimals. Okay, it's basically anything. I'm going to say at all rational numbers. Okay, in fact, it even includes irrational numbers. It includes any number you can think of, any number on a number line. Okay, in fact, it's any number you can deal with in high school. We don't deal with imaginary numbers and complex numbers and stuff like that. So it's basically any number you can think of. Okay, I'm going to show you the second method. That's called interval notation. I actually think this method is easier. I think that you should use it. You should be more comfortable with it. But I am going to ask you to learn both methods. I'm going to ask you for a couple of reasons. First of all, your first test, I'm going to say you have to write it both ways. But the bigger reason is you're going to see them both in future years. So I need you to be able to read it, even if you can't write it. Okay, so we do need to learn them both. Okay, this one, instead of using greater than or less than symbols, uses brackets. Not these kind of brackets. Those are for sets. We're not using those. Okay, so what does this one say? It's the same question, except this time it's going to be done in interval notation. So I'm going to say x is greater than or equal to -6. Here's the way this looks. I'm going to go from -6 all the way up to infinity. Okay, now because it's equal to, I'm going to put a square bracket around -6. And I'm going to put a round bracket by 6 because I can get up to infinity, but I can't quite reach it because no matter how far we go, there's always one bigger number. So for infinity, we always use round brackets. We use square brackets for the numbers unless it says not included. Okay, now I'm going to give you examples of that as we try some questions coming up. Okay, let's try one. So we'll do this question first. Ignore the one on the left just for a minute. Okay, first, tell me what the domain is, the x values for this graph here. Okay, I'm going to say from -4 to 5. Now, that's not quite true though, because -4 and 5 have different dots. -4 is included. Okay, if you want to make a note here, this means included. This means excluded. So we're only going up to -5. We're not including it. Okay, so from -4 to 5, we should say including -4, but not 5. Okay. So before I do the range, let's now write that in different methods. Set notation. Okay, what I want to do is I want to say x is between those two numbers. So I'm going to write the smaller one here. I'm going to write x is in the middle of -4 and 5. The question is, what symbols do I say? Well, I want x to be bigger than or equal to -4, but I want it to be less than 5. Okay, now notice the symbols. Equal to because -4 is included. not equal to because 5 is not included. Okay, and we could say x is a real number. Again, I don't need to have that part. Okay, I used a comma there. You can use a comma. You can also use a line here, which just means such that. Okay, let's try it in interval notation. So this is just from -4 up to 5. Square bracket included, round bracket not included. Okay, let's now write the range. What is the range? Well, range is y is 2. That's the only value. Okay, set notation, that's easy because I can just list the number 2 because that's the only one it is. Okay, and now the question is, how do I do this in interval notation? Because there's no interval. It's only one value. I'm just going to say y is 2. That's the only value possible. Okay, by the way, this is one reason why we might want to learn how to do both methods. The set notation just seems like it fits better there. Okay, so I want you to pause the video. I want you to take a shot at this next question. See if you can write the domain and range in those 3 different methods. All right, let's give it a shot. The domain. Does it make sense? It goes from 1 to infinity. Okay, so I'm going to say from 1 to infinity. Okay, what does that look like in set notation? Well, you have a couple of choices here. I could say from 1 to infinity, so x is greater than or equal to 1 and less than infinity. It might be easier just to do this though. Let's just say x is bigger than or equal to 1. Okay, that's all I need to say. X is just bigger than 1. Okay, such that x is a real number. Okay, with interval notation, it's from 1 to infinity. All right, range is a little trickier. We're going to get a little messed up with this. So the range is supposed to be from -2 down to -infinity. The problem is you would never say it that way. You would say from -infinity to -2. Always least to greatest. Okay, you don't start with a smaller number. Okay, that's important for the next 2 as well. So here I'm going to say y is less than or equal to -2. And then you could say y is a real number if you want. Okay. Interval notation. Lots of people are going to do this. They're going to say -2 to -infinity. If you do, I'm going to mark it wrong. It should be -infinity to -2. Okay, it must be in that order. Okay. I'm going to run out of time here, so I'm going to pause the video and we'll continue with the next one.